So now that we've taken some time and looked at Steve's render description file, Steve also created a very quick mock-up of a real-world render description file over on the whiteboard, and then we jumped into Houdini and we acted as if we were the script, walking through the process of assembling our rendered passes based off of the information found over in that demo render description file over on the whiteboard. It's now time for us to begin creating our script, because everyone should have a relatively clear understanding of what the script needs to do. But before we begin writing our script, let's spend just a minute and talk about the Python scripting language. First off, Python was integrated in Houdini back in version 9.0. As of 9.5, the integration is not yet complete, but with each new iteration of Houdini that is being released, side effects continues to get closer and closer to that 100% integration mark. Rest assured, there is plenty of functionality available already, and we will be taking advantage of that as we write this script. Now, what are we expecting of our viewers? We are not expecting for our viewers to be professional programmers, but we do expect for you to have a basic understanding of programming as well as a basic understanding of some common programming terminology. Things such as what's a variable, what's a function, and even what's a class. Now, this will not be a Python 101 type course. Over at 3dbuzz.com, we do offer an introduction to Python, as well as some Python videos that walk you through the creation of a set-driven key tool for Houdini. And with that, it's pretty nice because we spend a bit of time talking about how to put together a graphical user interface and then how to tie that into your scene, which is pretty neat. Now, in the following videos, there's a bit of code that's going to be written. Steve will make sure that he explains what every single line is doing, though we understand that if some of you that are watching these videos are new to the world of programming, that you may find yourself needing to go to the internet and do a little bit of research. If you put forth just a little bit of effort into tracking down some of the commands that Steve will be using, you'll find quickly that it's really not that bad. And then you can always come back and re-watch the videos. But you're going to be happy to note that in this video, Steve's going to spend just a minute and kind of review just a little bit of the basics, and he's also going to talk about some file I/O operations as well. So I just wanted to get that out of the way first. Again, this is not a true introduction to Python, though this is a technical director's course, so we would hope that everyone that is viewing these videos have some sort of basic programming understanding, because all technical directors will need that at some point or another. So with that, Steve, let me go ahead and turn it over to you.
Well, thank you very much. So we're going to be building our tool as a script, and I say tool, it's going to help us with our rendering, but it's not really going to be a fully fledged tool, because this is the first look into Python in terms of the TD course, and we're not going to take all the time it would require to develop this into a fully fledged tool with a graphical user interface and a whole load of options. We're going to keep things nice and simple and focus on the functionality of the script rather than turning that script into a tool. So we now have a couple of options of where we're going to work in terms of editing the script and executing the script. We could work in an external Python editor and then import our script into Houdini and execute it. We could work directly into the Python shell and type in our script and execute it. The way I've chosen to work to keep things nice and simple, I'm going to create a new tool up on our shelf. I'm actually going to create a new shelf to store this tool as well. And that tool is going to allow us to enter Python script into the tool, and then when we click on the tool, it's going to execute our script. So let's go ahead and do that now, get our shelf set up and get a tool set up.
Sounds good.
So I'm going to click on the plus button on our shelves and create a new shelf. I'm going to give this the shelf of TD tools.
Okay.
Yeah, and a label of TD tools.
Sounds good.
And if we accept that, we're going to see we've now got a TD tool shelf, which is empty, and we can add tools to this shelf. So I'm going to right click on the shelf and create a new tool. And we can come over to the options tab and give this tool a name of something like, let's see, TD vol2 underscore render manager, something like that, and a label of TD vol2 underscore render manager. And I'll leave the icon with the default. And if we accept that, we've now got a tool that if we were to click is going to execute the script that's within that tool. If we right click on the tool and come to edit the tool, This is the script that will be executed. We can see the script language is set to Python. So we're going to do all of our work when dealing with the script itself inside this editor. We can then make any changes and accept that out. And to then execute our script, we simply click on the tool icon. So that's the workflow I've chosen to use so that we can focus on the script itself and not so much on the implementation of the script into Houdini. But that's going to be when we come to actually create our script. What about now when we're just talking about some of the fundamentals? Well, the easiest thing is to bring up a Python shell and just type some Python code into that shell. So I'm going to bring up a new pane of type Python shell. And in the Python shell, we can now start typing Python scripts. And there's a few things I wanted to cover in terms of Python. The most important thing we can probably see when we executed the script manually, we're dealing with parameters and nodes all the time. So how do we get access to nodes in Houdini, and how do we get access to parameters on those nodes? Well, let's talk about our render node, since we're dealing with our render node a fair bit with our script. To get access to a node, we can call the who module, which is the master Houdini module in Python, and from within there is a node method. And the node method allows us to specify a path to a node, and in doing so, that's going to return effectively that node as an object to us. So let's specify the path /out /mantra1, which is going to point us to our mantra1 node. If we were to execute this, you're going to see that it's going to return and print out the fact that it's returned as a ROP node, which is a render outputs node, which is our output mantra1. Now, what if we actually want to work with this node? Well, we can take the returning variable that's coming from our who.node call. We can store that into a variable so that we can then reference it later. So let's create a variable that we can call something like render_n for render node, and we can set that equal to who.node, and we can grab our /out /mantra1. And now when we execute, we won't get anything printed out to the shell, and instead we can now tell the shell to print out our render_n, and we'll see that render_n is mantra1. It is this node. So now we have render_n. We can work with render_n as if we're working with this node. We can access parameters to evaluate them, see what the values are. We can access parameters to set them. We can do a huge amount. So what if we were to want to access the candidate objects parameter on our node, since this is one of the parameters we will be dealing with? Well, once we have a node stored in a variable, we can call the .evalPalm method, and that's going to allow us to evaluate whichever parameter we specify. So let's grab our render node .evalPalm, and the parameter we can specify, well, how do we know the parameter name? If we hover our mouse over candidate objects, the parameter name should eventually show up. There we go. The parameter is vObject, all lowercase. So if we were to evaluate the vObject parameter, and I am passing both parameters and nodes as strings and using single quotes to specify that string. So vObject, we can see that the evaluation comes to stadium import, which is whatever we have currently typed into here. What if we were to say, okay, we also want our pool and our ladder inside here? If we were to re-evaluate that parameter by pushing up to grab our previous line that we executed, then enter.
Arrow.
Yep, and then enter to execute that again. We can now see we've got stadium import, space pool, space ladder within this parameter. So that's how we can go about evaluating parameters. How about setting parameters? Well, that's really fairly easy. We can call on more functionality of our node, and that functionality is the palm for parameter functionality. And what that's going to do is allow us to specify a parameter, and we're dealing with vObject in this case, and that will return to us a parameter object. Now we could store that into a variable and then work much like with our render_n, or we could ignore the fact that we are going to store it and instead simply call functionality of whatever's returned. So if we put a dot on the end, what's going to happen is render_n is going to evaluate the parameter vObject, returning the parameter object to us, and then it's almost as if we have that object, and with that object say dot and call a method that belongs to that object. And what if we want to then set that parameter? So we say render_n's vObject parameter, let's set that to a value, and I'm going to set that to a value of, let's say we set it just to character. If we execute this by pushing enter, we've now taken this parameter and filled it in with whatever we specify here. So we can see that we're going to be taking extensive use of evalPalm and .palm.set in order to grab parameters to save them and set parameters to whichever values we want to set in our script. there's a little bit about accessing parameters in Houdini. Well, how about file input and output? Well, in order to do file input and output, it would be really useful to have a file to work with. So I'm going to jump over to our TD Vol2 folder. I'm going to delete out these test renders that we've already done. And I'm going to right click and create a new text document, which I'm going to call example.txt. And if we open this up, Notepad will open up, and let's just create some random text. So I'm going to say this is line number 1, and let's put an empty line in there, and then let's say line 3. This is some text. This is in a file. Another line, just some random text, and then final line. And if we save this, we can now load this file in, and we can run through this file line by line. So to load in a file, what we're going to do is we're going to call on a function called open, which is going to take in the file name that we want to open and whether we're opening it for reading or writing. And that's going to return to us a file object. And to work with the file after we've opened it, we really need to have access to this file object. So I'm going to save it into a variable, and I'm going to call that variable FOBJ. So we're going to create a file object variable, which I'm going to set to equal whatever comes back from opening a file. What file am I going to open? I'm going to open C \, and we're going to grab the projects folder. And inside the projects folder, we want TD Vol2. And inside that folder, we want to grab example.txt. Now we do have to be careful when dealing with file names because of the fact that we've got backslashes, and because of the fact that backslash is an escape character. To actually use a backslash within a string, we need to use the double backslash, because backslash actually equates in a string to the backslash character, whereas backslash is telling Python to think of it as an escape character, which if you look into string formatting, you'll find a lot more about. So we need to make sure all of our backslashes are actually double backslashes. So we're going to open the file C \projects \td vol2 \example.txt. So this guy. And how do we want to open that file? Well, I want to open this file for reading. Now, we don't have to specify for reading. That is the default. If we just to open a file and not specify a second parameter, it will open for reading. Just, especially because I come from a C programming background and I like the clarity of knowing, am I opening a file for reading or for writing? I am going to manually specify R for opening for reading. So with that, that's going to open our file, and we can print out FOBJ to get some information. And it's just going to tell us that we've got the file C projects TD Vol2 example.txt and where in memory that object is existing. So now that we've got that file, we can start working with the file. We can read the data from the file line by line by calling on methods that belong to our file object. So let's let's save into a variable called nextLine the first line of our file, and to do that we can call on the readLine method of our file object. So let's grab readLine, and if we execute that, that's going to save into nextLine the first line of our file. And what was the first line of our file? That was this is line number 1. So if we now print out nextLine, we should see this is line number 1, and we've also got that space because of new line terminating. And whenever we read in a line from a file, we always get a terminating new line character on the end, so that's dropped us down that extra line. So now, what if we were to want to loop through every single line in that file and print it out? Well, that's really easy. What we can do, we can use a while loop, and we can say, okay, let's keep checking nextLine, and as long as nextLine is not equal to an empty string, Houdini and Python will return an empty string when the file has got to the end. So once we get to the final read line and we call read line, there's no more file to read, Python's going to return to us into nextLine an empty string. So all the time we're not getting an empty string, we know that we're dealing with reading in a new line of text. And we want to, while we're doing that, keep looping through, and let's keep printing out whatever that line's equal to, and then read in the next line. So then read in next line as fobject.readLine. You'll notice that since we're dealing with a while loop, I have indented the code that I want to belong to that while loop. And you'll also notice the syntax of the while loop is while we have an expression, which is next line not equal to empty, and then we have a colon to indicate that we're now beginning the block of the while loop.
And the indentation is extremely important because that is the way you specify to Python that these indented lines belong to this while statement.
Exactly. Without the indentation, Python will not be able to know that that belongs to the while loop, because unlike other languages, we don't use braces in Python to declare blocks of code. So that's all that I want to belong to the while loop, so I'm going to enter to drop down. Now if I enter again, Python's going to know when we're working in the shell that we've finished that while loop, and it's then going to execute this while loop. So we're going to see all of the lines of text printed out from our file. So we've got, this is line number 1, the new line because we read in a line, then our blank line because we put a blank line in the file, another new line, then line 3, another new line, this is in text, this is in a file, another line, then our final line, and once we hit our final line, we've ended that while loop because we've jumped out of the file. Read line command will return into next line an empty string, which then when we check, does next line equal an empty string? Well, next line not equal to empty string, when it is equal to empty string, is going to evaluate to false. We're going to jump out of that while loop, and so we're going to finish looping through the file. So a couple of other things I'd like to talk about very quickly would be functions and a little bit about classes. So we're going to be defining functions, which is a way of allowing us to basically group together a chunk of code that we can then execute by calling the name that we've given to that code. And to do that, you simply type def to define a new function, and then we can specify the function name. So I'm going to call myfunc. Any parameters we want to take into that function, in this case I'm not going to take in any parameters. When we deal with the functions that we're going to define in our script, I'll talk a little bit more about parameters and bringing parameters into our functions. And then again, like when declaring a while loop, I'm using a colon to declare that the block of code belonging to this definition is about to start. I'm going to indent since we want our code to belong to this function, and I'm simply going to do a single print statement within this function whereby I'm going to print out hello world, and I'm going to end that with a new line. And then I'm going to enter down again to accept that function definition. So now we have a piece of code that's going to print out hello world that we can refer to by calling my function. So now if we call my function like any other function or method in Python, by calling myfunc and then open and close parentheses, if we push enter, it's going to execute this code that we've defined and print out hello world. Now, in terms of classes, we're not going to be using classes in the traditional sense of classes. I'm going to be using classes in the script more or less as a way of storing multiple variables in one location. So what we're going to do, we're going to use a class basically like a container, and then have the members of that class act like a series of variables. It's almost like creating a data structure if you're familiar with working in C. So what we're going to do, let's create a class that we call myContainer. And again, we need to end that off with a colon. And what I'm going to do, we don't technically in Python have to declare which members belong to your class when you're actually creating the class. For clarity in the code, and because people coming from other languages may well be used to the fact that you do in other languages have to declare the members, I'm going to create the constructor for this class, which when we call on an instance of this class, this is effectively a function that will get called. And inside this, I'm going to declare all of the members that I want to belong to this particular class. So I'm going to define a function, and that function is a special function with the name underscore underscore init underscore underscore, and it's going to take in self, which is a special keyword that allows us to take in our instance of ourself. What's going to happen is when we create an instance of this class, so we create an instance of our container whereby we can store stuff into it, we're going to call on the init function by default, and we're going to pass whichever instance we've just created into this function. And all I'm simply going to do is say that self, which will be whoever's just called this function, is going to have a box A parameter, a box A variable that we're going to store the letter A in by default, and is going to have a box B member that we're going to store a letter B in by default. So I'm using self.boxa to say dot means a member of self, so self.boxa, boxa is a member of self, and in that I wish to store A. And then self.boxB, I wish to store B into. So it's a very simple function that's simply going to set up two members for our class and give them default values of A and B. So I'm going to enter to accept the definition of both the init function and our class. And now we can create instances of this class. So we can say my box, which is a variable like any other variable. I want to make my box be a myContainer object. And to do that, we simply call on myContainer. And that's going to allow us to create an instance of myContainer. So now if we were to print my box, we'll see that it is a myContainer instance. We have access now to box A and box B within my box because they're members of the myContainer object. So we can say myBox dot box A, and we can see that that's equal to A. We can do myBox dot box B and see that that's equal to B. We can go ahead and say that myBox dot box A is now going to be equal to S, and we can reassign. So even though we've given it a default value, we can now go in and reassign a value, which if we were to print out myBox.boxA, we can see is now equal to S. This is going to be incredibly useful for us because we're going to need to store a little bit of information about our render setup when we're running through the script, and I'm going to simply, to keep things nice and easy for storage, I'm going to create a class to contain all these within. We're going to have things like our object name, our light name, etc. stored within this class, so we can simply come in, create an instance of a class for each render, store the information into the members of that class, and then we have a nice container containing all of the information we need. So I mean, that really was a very quick overview, more of a primer than anything.
Did you want to spend just a second and talk about concatenation? Because that's going to be somewhat important as well.
Yeah, okay. So let's create a string type variable, which I'm going to call my string. And let's set that equal to the string
Steve.
So if we were to print my string, we'll see that my string is equal to Steve. What if we were to say that I want to append something onto the end
like
of
your last
Steve?
name?
Yeah, so we could do that in two ways. We could reassign into string Steve plus the new string twist, and that's going to basically take Steve as a string, take twist as a string, and append them. But you'll notice we don't have a space in between, so if I was to print out my string, you're going to see Steve twist without a space. We could say my string equals, as I push enter instead of single quote, Steve plus, then have a string with a space in, plus twist. And if we were to now print my string, we're going to see that we have Steve space twist. But we could also say, what if we just were to set my string equal again to Steve, and then were to take that and say my string plus equals, so take whatever is in my string and now add to it space twist. Now if we print out my string, we're going to have taken Steve and added onto the end space twist, so we're going to see Steve twist again.
And I'm sure you guys can see why this is going to be very important, as Steve was talking about the way his script was going to work and use the render description file. We're going to be assembling that long name. So in doing that, we're going to be making use of concatenation.
Exactly. Well, let's jump back over to the whiteboard very briefly, and we saw that we're going to take a variety of pieces of information to build together our directory structure and our file name. So we're going to need to concatenate a number of strings to build the final end result of this.
That's right.
Cool. Is there anything else that you think?
No, I think that's a very quick introduction, and with that will allow us to bring this video to a close, and in the next video, we'll begin coding. Thanks a lot, everyone.